Welcome dear students in the class. Today we will discuss the topic analytic functions in the book complex variables. Analytic functions in the complex variable. So we will tell you first the derivative. If a function is fz is single valued in a domain D, then derivative of fz at the point z is equal to a is defined as f dash a is equal to limit h is tending to 0 f a plus h minus f a upon h if this limit exists uniquely. Means this limit is independent of the path along which h is tending to 0. It is notable thing that if this limit will not change when we change the path of h is tending to 0 or we goes in any way we tends h tends to 0, this limit if does not change, if it is unique, then we say that the function fz is differentiable at a point A. Now we will tell you about analytic function. Consider a single valued function fz in a domain D. Then fz is said to be analytic at a point z is equal to a if fz is differentiable in the neighborhood of the point A. Means neighborhood means the set of points. Neighborhood of A is defined as modulus of z minus A is less than delta. Delta neighborhood means the set of all the points which satisfy modulus of z minus A is less than delta. So the function will be differentiable at the point A if it is differentiable in the neighborhood of the point A. Clear? If the f dash z exists every point in the domain D except a finite number of exceptional points, then fz is said to be analytic in D and it is referred as analytic function. The exceptional points are called singular points or singularities of the function in that domain. Clear? If f dash z exists at every point of the domain D, then we say that fz is regular in D. So the term regular holomorphics are synonyms of analytic function. What is singular point? A point z is equal to z0 is said to be a singular point of fz if fz is not analytic at the point z0, means f dash z0 does not exist. Now we will tell you the necessary condition and sufficient condition for a function fz to be analytic. The necessary condition that a function w is equal to fz is equal to uxy plus ivxy, where uxy is the real part of the analytic function and v is called the imaginary part of the function. It is analytic in domain D, then u and v satisfies Cauchy-Riemann equation. So it is necessary condition. If a function is analytic, then it will satisfy the Cauchy-Riemann equations, and these equations are day var u upon day var x is equal to day var v upon day var y. Or in another short notation, we write ux is equal to vy. And another is day var u upon day var y is equal to minus day var v upon day var x. So uy is equal to minus bx at every point of the domain D. This is the necessary condition for a function to be analytic. Means if a function is analytic, then it will satisfy Cauchy-Riemann equation. Its proof is very simple. We will apply the definition of analytic function. Why? How? Suppose fzw is equal to fz is equal to uxy plus ivxy, and it is given that analytic, the function is analytic. So we find by the definition of differentiability dw dz from two different paths. First, we will tends delta z tends to 0 along real axis, and in the another way we say that delta z tends to 0 along imaginary axis. But it is given that the function is analytic, so these two values will be equal, and equating these two values and separating the real and imaginary parts, you will get the Cauchy-Riemann equations. Day var u upon day var x is equal to day var v upon day var y, and day var u upon day var v y is equal to minus day var v upon day var x. Means ux is equal to vy and uy is equal to minus vx. So it is necessary condition. Means if a function is analytic, then it will satisfy Cauchy-Riemann equation. Now we will tell you about the sufficient condition. Means it says the function fz is equal to u plus iv is analytic in a domain D. Yeah, will be analytic in a domain D if two conditions are satisfied. First, u and v are differentiable in D and satisfy Cauchy-Riemann equations. Means ux is equal to vy and uy is equal to minus v. And the second condition is that the first order partial derivatives means ux, uy, vx, vy. How many? 4 first order partial derivatives of u and v are continuous in domain D. Means if a function satisfies these conditions, then it will be analytic. Means Cauchy-Riemann equations only are not the sufficient conditions for analyticity. And its proof is very simple. Suppose that fz is equal to u plus iv is equal to uxy plus ivxy is given. So the first order partial derivatives, it is given that first order partial derivatives are satisfying Cauchy-Riemann equations. Means day var u upon day var x is equal to day var v upon day var y, and day var u upon day var y is equal to minus day var v upon day var x. Using this, the continuity and differentiability, and simply applying the condition of continuity and mean values theorems, proceedings, and finally we get that the function is analytic, and in the result we find that it comes out in the form dw dz is equal to d var w d var x. It is a very nice and important result for the analytic function chapter. If we have to find out f dash z, means f dash z is equal to dw dz, and from this sufficient condition it comes out that dw dz is equal to d over w d over x. D over w d over x means it is equal to d over u upon d over x plus I d over v upon d over x. So these are the sufficient conditions. So in summary, you will remember that if a function is analytic, then it will satisfy Cauchy-Riemann equations, means ux is equal to vy and uy is equal to minus bx. Secondly, sufficient conditions conclusion is if a function which satisfy the two conditions. First condition is four first order partial derivatives of u and v are differentiable and satisfies Cauchy-Riemann equations, means d over u upon d over x is equal to d over v upon d over y and d over u upon d over y is equal to minus d over v upon d over x. It is first condition, and the second condition is that four first order partial derivatives ux, uy, dx, dy are continuous in domain D. If these two conditions are satisfied, then the function fz must be analytic. And in the result of sufficient condition, we find that dw dz comes out to be d over w d over a. D is equal to dw dz, means f dash z is equal to dw dz. It is equal to d over w d over x and it is equal to d over u upon d over x plus I d over v upon d over x. And now a question arises. If a function fz is equal to uxy plus ivxy is analytic, where uxy is the real part of analytic function fz and vxy is the imaginary part of the analytic function. Now the main question arises here, if you have given the real part of the function or imaginary part of the function, then someone asks you that find the analytic function. Means if the real part of a analytic function uxy is given and you have asked to find fz, so in summary we have to construct analytic function. So in construction of analytic function, a mathematician Millans and Thompsons give a method to construct a analytic function. Here we know that z is equal to x plus iy. So and z bar is equal to x minus iy. From here we find that x is equal to z plus z bar upon 2 and y is equal to z minus z bar upon 2y. And we know that analytic function w is equal to fz is equal to uxy plus ivxy, when u is a function of x and y and v is also a function of x and y. Replacing the variables x and y by z, the variables z and z bar, it comes out, it is a function, w is a function of u. In place of x, we put z plus z bar by 2, and in place of y, we put z minus z bar upon 2i. So, plus iv z plus z bar by 2 in place of x, and z minus z bar upon 2i in place of y. So it is a function, and it is given that this function is analytic. And it is clearly, we see that w is equal to, this is an identity. So we said, put x is equal to z and y is equal to 0 in this identity. When imaginary part is 0, it means z is equal to z bar. So we put z is equal to z bar in this identity. W takes the form, w is equal to fz is equal to u z0 plus IV Z0. Okay. Analytic function takes the form W is equal to Fz is equal to U Z0 plus IV Z0. Now we know that F dash Z is equal to dW dZ is equal to dAvar W dAvar X. It is equal to dAvar U upon dAvar X plus I dAvar V upon dAvar Y. Using the Cauchy-Riemann equation, we find that F dash Z replace the V with the help of Cauchy-Riemann equation in form of U, because we have given only U, not V. So f dash z comes out dAvar u upon dAvar x minus I dAvar u upon dAvar y. We have given u, so we find dAvar u upon dAvar x, put x is equal to z and y equal to 0 in dAvar u upon dAvar x, and denote it by phi 1 xy or phi 1 z0. Same, repeat the same process in dAvar u upon dAvar y. Put x, find dAvar u upon dAvar y and put x is equal to 0, x is equal to z and y is equal to 0 in it. We get phi 2 z0, and from f dash z0 it comes out f dash z0 is equal to phi 1 z0 minus I phi 2 z0. And integrating, we get f dash fz is equal to integration of phi 1 z0 minus I phi 2 z0 dz plus some constant c, where c is some constant. And integrating this, we find a analytic function fz. This method was given by mathematician Millens and Thomson. So this method is called Millens-Thomson's method of construction of analytic function. And in the next lecture, we will explain this method with the help of a example. Okay, so prepare analytic function and solve some problems of construction of analytic function. Means solve some problems where uxy is given and you have to find out f that. Okay, prepare well. Thank you.